Today we are going to learn about the t-test. We will learn some background information about the t-test, then we'll learn what the t-test is used for and why it is important to learn. Then we'll learn how to do a t-test. A t-test is a method of testing hypotheses about the mean of a small sample drawn from a normal distribution population, when the population standard deviation is unknown. Now this sounds very complicated with all the big words and math talk, but it is actually very simple. The null hypothesis is the belief that we are trying no test or show there is enough evidence that the null hypothesis can be believed. The normal distribution population is just a population that does not have extreme data values that show it from the bell curve, the normal shape for a distribution of data. And these are the great 8 steps used for solving the t-test. The t-test can only be used for quantitative data, which uses this symbol for the mean. And there's only one set of data that is used for a t-test. So there are 8 steps to solving a t-test problem. The first one is to name the test. The second step is to check assumptions for randomization, independence, the 10% rule, and normalcy. And to find normalcy, you use a histogram. So you will go to stat plot, make sure your plot is on, go to histogram, make sure X is list 1, and then you will graph, zoom 9, and it has to be roughly symmetric with no outliers. Okay, and then next we're going to state the hypotheses. So this is the null hypothesis, and this is the alternative hypothesis. Then we will find a test statistic by using the calculator. Step 5 is to draw the picture that is shown on the calculator. Step 6 is to calculate the p-value, which is the shaded area of the picture. On step 7, we will make a decision regarding rejecting or failing to reject the null hypothesis. And then step 8, we will write a conclusion in context. So now let's do an example problem. So the example problem says, the level of dissolved oxygen in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the dissolved oxygen level at 15 randomly chosen locations along a stream. Here are the results in milligrams per liter. A dissolved oxygen level of 5 milligrams per liter puts aquatic life at risk. Can we conclude that aquatic life in this stream is at risk? Carry out a test at the test significance level of 0.05 to help you answer this question. So as we go through the steps, step 1 is name the t-test. Step 2, it states that all locations are randomly selected. The locations are independent of each other. And as we can see, it is a roughly symmetric curve. So now we find the null and alternative hypothesis, and so it says 5 milligrams per liter, so our null hypothesis is equal to 5, and we are trying to find if the aquatic life is at risk, so we put mu is less than 5. So to find the t-test, we go back to our calculator, and we will turn off our stat plot. We go to stat, edit, and put in all of our data, which we've already done. Then go to stat, over to tests, select t-test, make sure you have data selected. Your null hypothesis is equal to 5, list 1, frequency 1, less than, and then we'll select draw. So t is equal to negative 0.9426, which is our test statistic. and then we draw the picture that is shown on the screen and find our p-value as being 0.109. And since 0.089 is greater than 0.05, we will fail to reject H0, and we do not have enough evidence to show that the aquatic life is at risk in the stream that has dissolved oxygen levels below 5 milligrams per liter. So now we will do an assessment question. So a weight reduction program claims to be effective in treating obesity. To test this claim, 12 people were put on the program and the number of pounds of weight gain/loss was recorded for each person after 2 years. The data reported is shown below, and so it is your job to find the p-value and the test statistic. So do that on your paper now.
And he was like, he started calling out